Okay, there we go. On the test on Monday. Okay, there we go. Welcome. Sorry it's delayed. Very not complete notes, but we'll have a good time with this section. It won't be whoops, r equals 4 sine of theta. How was your weekend, Annie? I don't know who else joined. I feel like someone else just joined, but I could be incorrect because I have been known to be incorrect before. Oh, the person quit. They were like, you know what? This is not extreme for me. I don't need to learn 10.8. I need to go back to sleep and take a great nap. Okay. Very peaceful. Hi, Drew. Welcome. I hope your weekend was good. My weekend was great. Obviously, it was, yeah, it was pretty chill. Do you guys, just a question, let me know if you want the test next week, Monday, or would you prefer this Friday? We could have the test on Friday afternoon or Friday morning, or Monday, Monday sometime. We are going to skip chapter 11, but I will give an option for doing chapter 11 on your own, but then getting some credit for it. How would the test work? So you would need to take the test during, there would be a specific amount of time for you to take the test. And if you submit it late, you do not get credit unless previously discussed. So if you, for example, are in another country and can't take the test at the right time, then you can tell me and we'll arrange it. But if you are taking the test and suddenly say you have 15 minutes left and you're like, oh, can I have extension? You have to give a valid reason. So you can't be like, oh, well, I'm not going to finish. That's not a valid reason. I'm going to give plenty of time for the test. So it should be a problem at the test length. Okay. I might use a website for it, so I would send out a practice test on, if it's open notes, that's a good question. I think it should be open notes because Okay, yeah, it will be open notes, but it is going to be more difficult because it's open notes. So, uh, uh, I actually have it. Okay. Who else is anyone else joining? Well, only 2 people watching. Okay. Yeah. We need to show work. Yeah, so you do need to show work. Yeah, so it is, since it's going to be open notes, just expect some pretty challenging questions, like critical thinking questions. So, yeah. Okay. Okay, we're going to go through chapter 10.8 notes, okay? The deal is, I was originally going to be like, we don't need to do this, but it is a valuable exercise. You really want to do Bible? Is Bible due right now? When's Bible due, Drew? I mean, anyway, okay. I mean, I could do the lecture tomorrow. Well, you could work on it while having the stream up. And then if you have questions later, you can ask them. I'm not 2 to 5 sentences and keep ditching for that. Okay, so we're going to go over this notes. Before we begin, I have found out how to do this, how to change this into rectangular. I need to tell Annie because I just, I'm kind of sad that I didn't realize this. Okay, to change this into rectangular, you have to remember that sine of theta equals y divided by r. Okay, so if you plug y over r here, you get r equals 4 y over r. And then if you move stuff over, you get r squared equals 4y. Now r squared is x squared plus y squared. So if you plug this back in, you get x squared plus y squared equals 4y. Okay. So then, subtract 4y, subtract 4y, x squared, y squared minus 4y equals 0. Should equal 1, but yeah. I'm trying to think about that. Yeah, I think this is the formula that we end up getting. But I'll double check this. Anyway, oh, Daniel came. I did write notes. I did share the notes. Okay. You didn't give us our notes. Daniel, I did give you the notes. It's on the lecture link. It's just not in the material section. I'll post it in the material section in a little bit, okay? Okay, so graphing. The secret to graphing, so r equals sine of theta. Secret to graphing this is you just make a table with theta and r. So theta will just be, we'll just go through the circle with this. So it's a very long table, but 2 pi over 3, sorry, 3 pi over 4, oh no, we just skipped that, so 5 pi over 6, and pi. Now this keeps going, really it's just to trace what's happening. Do you want, Daniel, do you want to test this this Friday or next Monday? Okay, so we plug in theta into into 4 sine theta right here. We plug it in and we find out what r is. So in this, it's just 0. I'm just going to do the work. Sine of pi over 6 is 1/2 times 4 is 2. And this is 2 root 3, 4, 2 root 3, 2, 0. And then we're going to go into negatives. And all of this is going to just be the negative of this, okay? So this is all the positives, the negatives are going to happen. So in graphing this, we need to remember that our radius is how far from the origin we are. And the thetas are our angle. So if we plug in angle, at 0, we're 0. At pi over 6, we're at 2. Sorry, this is going to be kind of difficult. Pi over 6 is right here, we're at 2. Then at pi over 3, which is here, we're at 2 or 3, which is about right. It's pretty close to 3. It's a little more than 3, so it's like right. Okay. Then at pi over 2, where it's 4. Then here. Here. Okay. So what's going to happen is we're going to have this circle right here. Okay. And it's gonna rotate around that same axis over and over again. Okay. So it's gonna have this circle over and over again. Okay, next Monday. Okay, morning or afternoon? So, Catherine, the test, do you want it this Friday or next Monday? And the other question is, do you want it morning or afternoon? Morning would be between 9 and 11 or 10 and 12. And afternoon would be between 1 and 3. Usually, I think morning's the best bet. Okay, so in graphing a polar, all you really need to do is find the thetas, plug this in. Actually, let me show you something. How does the test work? I do have a website that I could use. We'll test it out with a practice test on Friday. So on Friday, we'll have a practice test, okay? Okay, so I have 3 people for morning. Catherine's for morning and afternoon. So Catherine's for both. So she just wants the test really badly. And Annie's like, you know what? I'm going to keep saying the test. Okay, for my sake. Is it Go Formative? Is that the one that I have? Sorry. I'm gonna look if I have this. I don't remember. Okay. On Friday, we'll do a practice test, okay? Okay. So, for graphing, it does have a time limit. It is a time limit test. It is open notes, but bear in mind, open notes is not necessarily easier. Okay, it's just, it might be easier for some people, but, you know, maybe if someone's ambitious and tries to map out the whole book in their notes, they will have access to it. Yeah, otherwise, it'd be hard. Okay, let's graph this one. R equals for cosine theta. Okay, so we need our theta, we need our r, so we have 0, pi over 3, sorry, pi over 6, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. Okay, Aditya, afternoon Monday. Dude, Daniel, it's in here. Let me show you. Go to here, go to here, go to here. Boom. Okay, hold on. Let me show you the power of. Okay, Daniel, here, lecture live. The notes are linked, are PDFs attached. You can either use a PDF or the Word document. Hi, Henry. Okay. Okay. The notes aren't that good today. Sorry, people. They're kind of not the best notes. I'm disappointed with them, to be honest. Okay. So let's plug this in. We get 4. Sorry, need a different marker. At 0. Yeah. 4. Then this would just be 2 root 3, 2, 0, 2, 2 root 3, and then 4, negative 4. Okay, so if we're graphing this, so Henry, you might have missed it, but 1, 2, 3, 4. We are going to determine whether the test is on Monday or Friday. If you choose Monday, it's either Monday morning or Monday afternoon. And understand that if you turn it in late, it will not count. So Catherine and other people who might have difficulty with internet, you need to get solid internet for Monday. So whatever you need to do to get solid internet, you need to do it. So Henry, what time? So morning would be either 9 to 11, 10 to 12. Afternoon is 1 to 3. Okay. So it seems like most people have said afternoon. So only Annie, you've said morning. Okay. Fiona says morning. We'll see what Rachel says. What I can do is have 2 different tests, and then so morning test and an afternoon test, and they won't have the same numbers, but they'll be the same type of test, and I can do that. How are we going to have the test? There's a website we're going to use. Okay, so you just plug this in. Boom. 2 root 3 is like right here. Then right here. Yeah, right here. Then right here. Then right here. This is not the best drawing, but okay. That's supposed to be right there. Okay. Roughly this. Sorry, people. Learning my angles. Okay. So when you're drawing this, cosine should be along this line. So if you have a cosine theta and an r, you're drawing along this line right here. Back horizontal. If you have sine of theta, you're going to be going up and down. Okay. Okay. It is open now. Okay, we can go with maturity. Okay. Okay, we're going to talk about symmetry. This is a very short lesson, so we should finish in the next 15 minutes, okay? 15 minutes, possibly. Yeah, maybe 15 minutes. Nah, maybe a little longer. Yeah, close. Close. Okay. There's 3 types of symmetry in polar coordinates, okay? I'm just gonna blow up our symmetry thing. Apologize. Actually, you know what? How do we do this? Okay. Yeah, I'll give you the review sheet. I need to send you guys your grades for homework. My apologies, been slow on that. So I'm going to do both of those. Okay, so symmetries. There's 3 types of symmetries. Symmetry with respect to the line. You know what? It should all be bolded. I don't like bold. Okay. Symmetry with respect to the line. Do you need me to blow this up, people? Of course you do. That's not the question. There we go. Now we're talking. Okay. Symmetry with respect to the line. Theta equals pi divided by 2. Okay. And I'm going to show you on paper what each of these mean. Okay. So right now, just symmetry with respect to the polar axis. I'm going to show you what each of these means, so don't worry about that. Symmetry with respect to the pole. It's being squared. Okay? So, what do each of these look like? Okay, I'm going to leave this up, but we're going to, it's going to be smaller. So, if you didn't copy it down, there it is. It will still be up on your screen, on the screen for a little while longer. You can always go back to it. Okay. Okay. The 3 symmetries. So symmetry with respect to the line theta equals this. No, I don't need this. Marker. Okay. Okay, with the line theta equals pi over 2. Okay. And this is actually, which line is that? Well, this line is our 0, and this is pi over 2. So this is the angle pi over 2. And symmetry with respect to it means you have some r comma theta here, right? And if we were to draw a dotted line to the other side, we would have r pi minus theta, or negative r comma negative theta. Okay? And the distance between these two is the same. So these two distances are going to be the same distance. Okay? So this is theta, rotation, this is theta. And this is pi minus theta. Okay? Okay, so this is the test going to be in Google Classroom. It is going to use a different website, possibly. So we're going to do a practice test on the website. If you don't take the practice test, you won't be able to give me feedback. So the key is, if you can give me feedback on the website, if you prefer the website, we'll just use the website. If website is not good at the practice test, we're going to do it on a PDF. Here's the key, guys. I can tell when people use other software to do the work for them on problems. So I can usually tell when someone kind of isn't doing the work. I have a pretty clear example of that in my last test. They didn't show any work, got the right answer, and the way they did it just didn't make sense to what we learned in class. Okay, so that's an important thing is keeping consistent with the notes tells me you did it on your own. The other thing is please don't call each other. If I do see tests that are similar, I will either call you, so we'll have a Zoom meeting, or I'll send an email, which both ones I don't want to do. So let's just not have this. So this is symmetry with theta equals pi over 2. Now symmetry with the polar axis. So the polar axis is this line right here. So this is our polar axis. Sorry about that. You know what? Let's not just have a crooked line randomly on our page. Let's try to get it. Okay, that's slightly better. Okay, so the polar axis, symmetry about it, will have some r theta, again, some point, and to know symmetry is it's supposed to be the same point, just reflected over this x-axis. Not x-axis, but polar axis. And this is basically r comma negative theta, or negative r pi minus theta. Okay, so both of these work. Okay, and this angle right here is theta, and this angle right here is negative theta. Okay, so this is symmetry about the polar axis. So if you go up and you go down, and it's the same point, same place, same degree difference, that's going to be symmetrical over the polar axis. Okay, a pretty straightforward one, as opposed to other ones that we will see. Okay, going to erase this real quick. So if you want to save it so that you remember where you were, you can always do that. So with respect to the pole, now the pole is our origin, basically. It's where our angle and okay, so symmetry with respect to the pole is basically a reflection over the pole, or negative r comma theta, or r pi plus theta. So if you were to do the angle, get to this is pi plus theta. Okay, so if a drawing has symmetry in one of these, you should be able to plug in something over here and it would work no matter what you have. So if r is 4 and you plug in negative 4, you should still get the same theta. Okay? Now this is key, there's specific shapes that fit all these different symmetries. Okay? So, next thing we're going to talk about is the test of symmetry. Okay? So the test of symmetry, so I'm going to leave that up. You can pause the video if you need to keep on the drawing if you need it, but we're going to move on. So test of symmetry. So one test for symmetry is going to be, so for the line, theta equals pi over 2. For this line, you're going to replace r comma theta with by r pi minus theta, or you're going to replace it by negative r comma negative theta. Okay, so we're just replacing stuff. Okay, to check this is our test. So to test for line, we're going to replace our normal r comma theta with r comma this or r comma this. If it still plugs into the equation, we're good. If it still works. If it doesn't work, we know something's wrong. So the polar axis. Okay, so what we do is we replace our same thing, r comma theta. Sorry. Sometimes doesn't go the way you want, but by r comma negative theta. Okay, really simple, r comma negative theta, or a little more complicated, negative r pi plus pi minus theta. Okay, so there's always two options to this. Okay, there's always two options. Okay, and for the pole, you're going to replace r comma theta by r pi plus theta, or negative r comma theta. Okay, so these are our three tests. Okay, now honestly for me, I'm going to highlight the ones I think are easier. Honestly for me, this is going to be probably easier. This is going to be probably easier. And this is going to be probably easier. Okay? So honestly, these three are probably your easier tests to find out the test for symmetry. Okay? Because these ones involve pi, and it's just a little bit messy. It's almost easier just to have our theta just replace it. Okay? There might be a reason to use these more complicated methods. Obviously, just complicated means one extra step, but there might be a reason. But you know, for all purposes' sake, it seems easier to use the highlighted portion. Okay, so we are gonna look at a quick test for symmetry, and then we're gonna talk about three examples. I'm going to talk about special polar graphs, and then we'll be done. So a quick test for symmetry. Okay, this is big stuff right here. The graph r equals some function of sine of theta. Okay, so r equals some function of sine of theta is symmetric with respect to the line theta equals pi by 2. Okay, so if you have r equals some function of sine of theta, it's going to be symmetric with respect to the line theta equals pi by 2. On the other hand, the graph r equals some function this looks like it's bolded. No, definitely it's bolded. R equals okay. equals some function of cosine theta. Now this one is going to be symmetric with respect to the polar axis. Okay? Really simple. So quick test, does that cosine, does that sine? And if it has sine or has cosine, you know it's one of these two. Okay? But what about so the pole is the one that actually you need to plug in. Okay, these two, there's quicker tests. Now, they might not fit the way you want it to. You gotta be careful. Okay? You gotta be careful. There is one we are gonna look at to just test it, okay? So we're going to look at an example. Oh, sorry. I'll leave that over here. There we go. That's better. Okay. So, I'm going to look at an example here. Example 2 is r equals 3 plus 2 cosine of theta. Okay? Now, here's the secret. See this right here? This cosine means that it's going to be symmetric with respect to the polar axis. Okay, with respect to the polar axis. Okay, but let's test it out, because I don't want you to just assume I'm right, because often I'm right. I want you to see that I'm right because I did the math. Okay, so the quick test tells us it's true. Let's test the long way. So the long way, we're going to plug in r comma negative theta. Okay, so r stays the same. So we got r equals 3 plus 2 cosine of negative theta. Well, cosine is an even function. So even function means cosine of theta equals cosine of negative theta. So, replacing this, we get r equals 3 plus 2 cosine of theta. Is this a true statement? Did this stay equal to the first one? Yes, you see this and this. So, this would mean it's symmetric over, I'm going to say with respect. You say with respect to. With respect to the polar axis. Okay. Is it symmetrical to the other axes? Let's check. Okay. So with respect to the line, theta equals pi over 2, we have r equals 2 plus 3 cosine of theta. So what we need to test it with is negative r comma negative theta. Well, if you plug in negative r equals 2 plus, we're asking the question, 3 cosine of negative theta. Well, this is still positive, so this would be negative r equals 2 plus 3 cosine theta. Is negative r equal to r? Is it equal to? No, this is not equal. So no, it's not symmetric. Okay, and then if you really wanted to test it out, what about negative r comma theta? Okay, does this work? This is not going to work because negative r, theta is going to stay the same. Negative r is going to make it so that we can't do it. It's an even function. Okay, even function even function, we learned this a long time ago, even function means that you plug in f of x equals f of negative x. Okay? F of x equals f of negative x. Oh, it's part of just the definition. You can check it out. Just plug it in. If you want to check, plug in numbers. They should always equal the same thing. Okay, let's try a different one. Okay, we have, what question did I put? Question 18. We can try a different one too. Let's just try more than one, obviously. It's worth trying more than one. 18. So we have r squared equals 25 sine of 2 theta. Okay, so our three tests. First, do we have a sine of theta? Yeah, we have a sine of theta. So we're probably symmetric over the power but let's just check. So we have three tests. Negative r, negative theta, if that works. Or r equals negative theta. Or negative r, comma, theta. Okay? Negative r, so negative r squared equals 25 sine of negative 2 theta. What does this become? This becomes r squared equals 25 sine of negative 2 theta. Is this true? Well, this negative, we've learned something that sine, if sine has the negative, it's an odd function, so the negative actually goes to the outside. So we have this. Is this a true statement? Well, this certainly isn't a true statement because the negative of this is not going to be the same as the positive of this. Okay? Even though that there's the r squared. The r squared doesn't change, but the right side does. So this would not be. This does not work. Now, what about this one? Okay, we can check this one real quick. Same thing. All we'd be plugging in is r here, negative here. So the negative would be on the outside, and we would still be stuck here. So this wouldn't be true. Okay, this can't work because the same result happens. So both of these don't work. I need to double check myself because sometimes I say things that may not be the case. Okay, this is number 18. Okay, I thought it was the right one. Oh, 18. Okay, so last part. Check this one. Okay, now if theta stays the same, but negative r, we plug in negative r. So we have 25 sine of 2 theta, nothing changed over here. What's this become? This becomes r squared, 25 sine of 2 theta. So if you're checking symmetry, the last part of the problem should be the same thing as the first part if they're symmetrical. Are these two symmetrical? Yeah, so this is true. So this is symmetric. Symmetric with respect to the pole. Okay? So there we go. Now, if you're asking yourself, why doesn't this follow our simple rule, our quick test? The reason is because this has a squared right here. That changes the whole dynamic. Okay, that square messes over our ideas and definitely doesn't appreciate the way the work we've done. It goes over. Okay, there's also 13. 13 I feel like is really simple. We could look at like 33. Yeah, Could look at 33. Basically, there's a lot of problems we can look at. Suffice it to say, we're just going to leave it for now. We'll come back to it, okay? For now, come back later. Okay, let's look at special polar graphs. Okay, so special polar graphs are actually going to be a series. There's a lot of them, but there's some rules. So lemicons, or limacons. Think of lima beans, lima, con. Okay, I don't think that's how you pronounce it, but I believe that's part of how we're going to do it. So limacons are going to be either r equals a plus b or minus b sine of theta, or r equals a plus b, a plus or minus b cosine of theta. Okay, where a is greater than 0 and b is greater than 0. Okay, now there's 3 cases. Actually, there's 4 cases. What if a over b is less than 1, a over b equals 1, 1 is less than a over b, is less than 2, or a over b is greater than 2. Okay? 4 cases. Okay, what about 1, less than 1? You're actually going to get this loop. So I'm just going to show it with cosine. You'd go over, kind of loops, comes back, and goes back. Okay, that's not a really good drawing. It should be more circular. So I'll try to give you a better drawing of it. So give myself something to work with. Okay, there we go. Got what I was wanting. Close enough. Okay. So it has a single loop. The second one, it looks almost like folds to itself. Okay, it looks almost like a heart, except without a point. So it's a heart without a point. So it's okay. Third one is gonna go over and have a little dimple. It's gonna have a dimple, but it's not gonna go that far. Okay. And the fifth one's gonna be even less. The fourth one is even less severe, where you almost don't see what happened. Okay. Basically, as we go further and further this way, it's going to become less and less so. Okay. So we're going to have 4 different drawings. The first one has a loop. Second one has pretty clear divot. Third one is a little bit less, and fourth one's even less. Okay. So we're looking at the ratio of A and B. Okay, A and B. So that's lemicons. Okay. If you need to pause it, feel free to pause it. But we're going to look at a Rose curve, and then we're going to look at a and then we'll look at a circle and a lemniscate. Okay, or a lemniscate then a circle. Okay, so a Rose curve is actually just going to be r equals a cosine n theta, or r equals a sine of n theta. Okay, now there's again 4 cases. What are the 4 cases? Even, odd, and even odd. Okay, so even for cosine, we'll look at odd first. So n equals 3. And if you have n equals 3, the Rose curve is going to kind of follow this pattern. Okay, rose curve is going to be like this. That's not a perfect drawing, but it's adequate. Okay, what about n equals 4? What happens here? Well, n equals 4 is going to give us, it's like a flower. Think of a rose curve as like the flower of the polar graph. Okay. Okay, this isn't perfect, but this is what this would look like. Okay, notice this is going to be symmetrical across the pole, across the line theta equals pi over 2, and across the polar axis. So this 4 actually makes this symmetrical. This one is only going to be symmetrical with respect to the the polar axis right here. Okay, so this is odd and even. Now there's so many other ones. Okay, guys, there's so many drawings of these. Actually, these are like one of my favorite pictures. That fact that you can make so many things out of this n theta is so cool. In fact, I did watch something where they tell how to make photographs on computers, and they're explaining how they did it with fingerprints, because they needed to compress how many fingerprints there are, and so it's just really cool. Anyway, just really cool. I think you should know that. But so we're first going to do odd with sine, plugging in this. We get 5 pointed flower. So kind of cool. Now, I'm sorry, it's not perfect, but this is kind of the idea right here. So, with sine, depending on, if it's odd, you get the number of petals of the n. If it's even, you get double the petals. It's kind of cool. So, cosine, you can even experiment. There's a program for this, okay? If you have a graphing calculator, which I would love to show you with a graphing calculator. Okay, so it goes like this. So basically, when you draw flowers like this, you're actually drawing lemniscapes. Sorry, not lemniscapes, rose curves. Okay, so part of me thinks, if we could just sit the day and you just experiment, just plug in different sines and cosines, you'll see how crazy it gets. Okay, so those are rose curves. Okay, so rose curves are these two things. Okay, now what about lemniscape? Lemniscape. Sorry, this just someone wanted to add more for nouns. So we either have r squared equals a squared sine of 2 theta, or r squared equals a squared cosine of 2 theta. Oh, what does the a do? Good question. What the a actually does in this case is the a, we're first looking at sine, sorry. The a is actually this distance right here. So this is a. Okay. And if it's cosine, so this is sine. This is the sine one. What's the cosine one? Oh, the cosine one's really cool. It's over here. Okay, just like that. Okay. And then, obviously, circle. It's not too difficult. But the last part of it, what's this look like for a circle? Okay. So, circle. If you have r equals a cosine theta, or r equals a sine of theta. So simple cosine is going to be here. Sorry, not the best circle, but an okay one. So a is going to be this length right here. It's going to be a. So this is cosine. And what about sine? Sine is going to be over here. Sorry about that. That's not a really beautiful circle, but it will do. Okay. Okay. We'll just kind of flip it. This is sine. And a is this thing right here. Okay? Okay. How do you draw this? Let's pull up our favorite site, Desmos. Why do I use Desmos, you ask? No, you don't ask, but I ask. Is because Desmos actually will show you sometimes the steps it uses. Okay, start graphing. Get the graphing calculator. Okay, you can actually just go to graph, and we can go to polar, open graph. So you can just close this right here. And we go R. Let's do a rose curve. R equals 4. Let's do 2 cosine 7 theta. Look at that. So A is actually going to be affected by this. If we wanted to, we could just put B right here, A right here, turn B. Oh my goodness, this is so cool. That is so cool. Look at that. 5.9 right there. Just letting you know, that's crazy cool. There's 6. You can just see it as it goes. Oh, 6.5. Look at that. You can make all kinds of flowers. There's 7. So it has these really cool shapes. Let's try sine. Obviously, this is just the most fun part for me. So what's sine gonna do? So, oh my goodness, that's crazy. Okay, well, let's just say I don't know what this is, what shape this is. But it is definitely, look at 0.4 right there. Man, that is a cool image. That very intersecting lemons. And then we get 1, that get these flowers. So at 2, we get a simple shape, but then if you go through the decimal points, it gets funky. And then 3, simple, yeah, obviously. Yeah. Anyway, it's just one of the coolest things. So, I hope you enjoyed it. It's one of my favorite things, is these drawings. Let's get some r squares in here. Let's get some a squared. And let's get sine of 2 theta. Okay, we don't have b, so b doesn't matter. But a matters. What's wrong with this? They don't like it that way. Depressing. Okay, we can't use the landscape. But we got r, a plus or minus, let's say plus b sine theta. And if you just change the b, you get some cool shapes where I have this. So as we approach 1, circle, or really, yeah, it's a circle. As you go away from 1, and as B gets bigger, let's start at 1. So the ratio of this is 1/2. If it's smaller than 1, which makes that inside become bigger, okay? But as you get closer to 1, you'll see that it changes, and as it transforms, it gets closer and closer to a circle, okay? So let's say 2, because it's easier to do. So it gets flat right there. You see that flat, but then as you get into a better fraction, it makes it go bigger. Okay? It's just fun to play with. Okay. Thank you so much for joining. The test is on Monday. I will put out a review guide, and I will give you guys your homework back here shortly. Hopefully tomorrow is my plan. But if you have any questions for me, I'm going to put out the homework this afternoon. The homework will be due on Friday afternoon, so you should have plenty of time to work on it. If you don't, you can just ask me. Okay? Thank you so much for joining. I know there's only like one of you left because I started talking about these drawings and they're so fascinating. But yeah, just have a great day. Hope you had a good weekend. And I will see you guys on Friday if you want to do reviews. Okay, bye.